Welcome to Deals of Today. So today we're talking about something called the Great Abstraction. Really, it's the story of how we build software today. It's not about a bunch of separate inventions, but one big continuous journey, a quest to get further and further away from the raw metal, to stop worrying about managing servers and start focusing on writing code that actually matters.
All right, let's kick things off with a number that just, wow, it tells the whole story. A recent Docker report found that 64% of developers are now using non-local environments as their main setup. Let that sink in for a second. I mean, just 1 year ago, that number was only 36%. This isn't some small trend, folks. This is a seismic shift. The future of software development, it's officially remote, it's flexible, and it is absolutely cloud native.
So yeah, this whole shift to the cloud, it's not just a passing phase, it's the new normal. But, with great power comes new challenges. As we build these incredibly complex distributed systems, we're also creating new headaches, new security risks, and new things to manage. And that is what this great abstraction is all about, tackling these problems one layer at a time.
Our journey starts right at the bottom, at the foundation, the hardware. For the longest time, if you wanted to run an app, you needed a server, a physical box. The first massive leap forward was figuring out how to stop caring about that physical machine itself.
And what was the key to that leap? The container. Now, don't just think of it as a box for your code. Think of it more like a complete, self-contained bubble. It bundles up your application with every single thing it needs to run. It's basically a lightweight, super portable version of just the operating system parts it needs without having to pretend to be a whole new computer.
Now this is where it gets really interesting. This is the classic showdown. Containers versus the older tech, virtual machines. See, VMs virtualize the hardware. That means every single one needs its own full-blown operating system. They are chunky. We're talking gigabytes. But containers? They do something way smarter. They virtualize the OS, sharing the host computer's core. And what does that mean? It means they're super lightweight. We're talking megabytes. And you can zip them around anywhere. It's just a completely different game when it comes to efficiency.
And bam, this chart just perfectly illustrates the impact. Inside the IT industry, container use has exploded to 92%. And why is that? Well, it's because IT is all about microservices these days, breaking down big apps into smaller independent pieces. Containers are a perfect match for that. Now, adoption is a bit slower everywhere else, but you can see exactly which way the wind is blowing.
Okay, so we've abstracted away the hardware. We've got our nimble, lightweight containers. But hey, they still have to run somewhere, right? So let's climb up to the next level, abstracting the actual infrastructure that runs all those containers.
And this slide lays out the evolution perfectly. At first, you were managing your own virtual servers, like Amazon's EC2, just to run your containers. Then came these fancy container orchestration services, like ECS or Kubernetes-based EKS, where the cloud company handles all the complicated management stuff for you. But the final step? That's where the vendor manages literally everything. You don't even see the servers anymore.
And that brings us to things like AWS Fargate. I mean, this is the ultimate abstraction at this level. You just hand it your container and say, run this, and it does. No more patching, no more worrying about scaling, no more managing servers at all. You just get to focus on your app. This is a massive, massive productivity boost for developers. It just erases so much operational work.
So we've dealt with the hardware, we've dealt with the infrastructure, but what about the day-to-day grind of actually being a developer? The next layer of abstraction isn't about servers or clusters at all. It's about getting rid of all that nagging friction that slows down the real work of building software.
So let's just ask it straight up. With all this incredible tech at our fingertips, what are the real bottlenecks? Where are developers still getting bogged down? And you know what? The answer might surprise you.
The Docker report here it's fascinating. You think the top complaint would be some complex technical bug, right? Nope. The number one pain point for a full 31% of developers using containers is simply trying to estimate how long a task is going to take. And right behind that? Task planning. So get this, the biggest headaches aren't about the hard tech anymore. It's all the stuff around the code, the coordination, the planning, the human element of it all. Okay, this brings us to the cutting edge, the next great abstraction. We've abstracted away machines, we've abstracted away infrastructure, and we're working on the friction. The next frontier is abstracting away risk itself by building security into the code's runtime in a totally new way. And the technology that's really leading the charge here is WebAssembly, or WASM for short. Now, don't let the web part fool you. It may have started in the browser, but what it's become is a universal, super high performance, and incredibly secure runtime that can execute code basically anywhere, including on your servers.
So why is WASM such a game changer for this next level? Well, it all comes down to security. WASM runs code in what's called a deny by default sandbox. I want you to picture a newborn baby in a perfectly sealed room. It can't do anything. It can't interact with the outside world at all. That's a WASM module. It has zero capabilities by default. It can't touch files, it can't use the network, nothing, unless you explicitly and very specifically give it permission. This is just a fundamentally safer way to run code than a container.
This quote really drives the point home, and it mentions a powerful technology called eBPF. Now, to put it simply, eBPF lets you run programs safely right inside the core of the operating system, the kernel. It's unbelievably powerful, but also kind of risky, and that's where WASM steps in. By running those eBPF programs inside a WASM sandbox, like the quote says, you can give them only the exact granular permissions they need and nothing more. It dramatically cuts down the risk.
So, let's just take a quick breath and look back at this incredible journey of abstraction. We've gone all the way from the physical machine up to abstracting the very risk that's baked into our software.
And really, this is what it all boils down to. Each and every step has been about peeling away a layer of complexity. It's allowed developers to go from managing individual machines to managing giant clusters of machines to now, finally, just focusing on the code and the business logic that actually creates value.
And that leaves us with one last kind of mind-bending thought. This whole trend, it's all about abstracting away complexity so that we humans can focus on higher-level problems. So, what happens when we reach the end of the line? What is the final abstraction when AI starts to abstract away the very act of writing code itself? Now that's a question we are all going to be exploring very, very soon.